This video is an introduction to hypothesis testing. The lesson goals are to state the hypotheses for testing a population mean, state the hypotheses for testing a population proportion, and recognize type 1 and type 2 errors. These, along with just an intro to what hypothesis tests are all about. Hypothesis testing includes a hypothesis or statement or claim about a characteristic, like a mean or proportion, of one or more populations. Then a hypothesis test is a procedure based on sample evidence that is used to test a statement or claim about a characteristic of one or more populations. We have the null and alternative hypotheses. Sometimes it's called the alternate hypothesis. But first of all, in a statistical test of a hypothesis, we have the null hypothesis, denoted by H sub 0 or HO or H naught, like an initial value, which is a statement that is presumed to be true unless there is overwhelming evidence in favor of the alternative hypothesis, denoted by H sub A. In other words, the null hypothesis is given the benefit of the doubt. A familiar example of HO and HA is found in our judicial system. HO is the defendant is not guilty, and HA is that the defendant is guilty. A jury must believe that the evidence demonstrates guilt beyond a shadow of a doubt in order to convict a defendant, which would be HA, the alternative hypothesis. However, the defendant only has to demonstrate that there is insufficient evidence of guilt in order to be acquitted, which is HO, that the defendant is not guilty. In other words, the null hypothesis, HO, the defendant is not guilty, is presumed to be true unless there's overwhelming evidence to the contrary. In our judicial systems, the defendant is innocent until proven guilty. So we have that same kind of thing in hypothesis testing. The properties of HO and HA, first of all, the null hypothesis, again denoted HO, is a statement about the value of a population parameter. This statement is assumed to be true unless we find sample evidence that it indicates it is not. If the sample evidence is strong enough to indicate it is not true, then we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. The alternative hypothesis, denoted H sub A or sometimes H sub 1, is also a statement about the value of a population parameter. It is a statement or claim that we are trying to find evidence to support. And you'll see as you study these that the null hypothesis is always going to involve equality to some value or equality between two parameters, whereas the alternative hypothesis is going to be that that parameter somehow differs, is greater than or less than or equal to some value or some other parameter. For example, stating HO and HA for testing a claim about a mean. Example is test the claim that the mean yield of a new variety of plant is superior to the standard variety, which yields an average of 2.34 pounds per plant. So the claim is that the average for this new variety is actually better, greater than 2.34. So that has to be the alternate hypothesis, because the null hypothesis has to be that the mean is equal to some value, in this case 2.34. Basically that the new variety is not any better. The new variety, yield of the new variety is equal to the standard yield. Whereas the alternate hypothesis here is the claim that the new variety has superior yield. For HO and HA testing a claim about a proportion, for example, we have testing a claim that Martha Brandon has overwhelming evidence to retain her seat as the incumbent in a race for the state senate. So this is about a proportion, the proportion of supporters. So the null hypothesis is that the proportion is just 50%. It's just a 50-50 chance. So that she does not have sufficient support to retain her seat, whereas the alternate hypothesis would be that the proportion of people that support her is actually greater than 50%, and she does have sufficient support to retain her seat. So again, keep in mind that null hypothesis has to involve equality, and the alternate hypothesis has to involve inequality in some way, either greater than or less than or not equal. So the main elements of hypothesis testing start by putting the claim into symbols and denoting it as HO if it includes equals and HA if it includes greater than, less than, or not equal. And then the null hypothesis is presumed to be true. And then sample data from a random sample are used to calculate a test statistic and a p-value, and those will be studied in the following sections in this chapter. Then the conclusion results in a decision either to reject or fail to reject the null hypothesis. And correspondingly, there is either sufficient or insufficient evidence to support the alternative hypothesis. Finally, there are type 1 and type 2 errors that can result. Even if all of the mathematics is done correctly, the conclusion can be incorrect. Type 1 error is rejecting the null hypothesis when in fact it is correct. The type 2 error is failing to reject the null hypothesis when in fact the alternate hypothesis is the correct choice. And again, a familiar example is found in our judicial system where the null hypothesis is the defendant is not guilty and the alternate hypothesis is that the defendant is guilty. A type 1 error would be convicting an innocent defendant, and a type 2 error would be letting a guilty defendant go free. In our previous examples of testing the claim that the mean yield of a new variety of plant is superior to the standard variety, the null hypothesis is that it's equal, and the alternate hypothesis is that it's superior. So a type 1 error would be concluding that the new variety has superior yield when it really doesn't. And a type 2 error would be concluding that the new variety is equal to the standard yield when actually it's superior. And finally, in the example about Martha Brandon, whether she has overwhelming evidence to retain her seat as the incumbent in a race for state senate, the null hypothesis is that P equals 0.5. Martha does not have sufficient support to retain her seat, and the alternate hypothesis is that P is greater than 0.5, that Martha does have sufficient evidence or support to retain her seat. A type 1 error in this case would be concluding that Martha has sufficient support when she doesn't, and a type 2 error would be concluding that Martha does not have sufficient support when actually she does. And this concludes the video on Introduction to Hypothesis Testing. I hope you found it helpful.